Hello, everyone. I hope you are well. In today's session, we'll be looking at the third and final portion of Learning Unit 2, one of the key concepts and learning outcomes, which is how to apply standard normal distribution and the relevant Z values to determine probabilities. So you'll find that in the section, it carries over to Learning Unit 3. So we basically set up the foundation for you in Learning Unit 2. It becomes a section that we look at in Learning Unit 3 in more detail. And it's one where you will be required to look at Table 1 of your appendix, as you will have come across in lectures. And you'll see that I'll be projecting the table as we go through these two questions, just so that you have an idea of how to determine the values of your table 1, which is where we get our probabilities from, and then also just for ease of reference as we go through these questions. So there's two questions we'll be going through today, and the first of them says that the patient recovery time from a particular surgical procedure is normally distributed with a mean of 5.3 days and a standard deviation of 2.1 days. If 26 patients were sampled, what is the probability that the recovery time from the procedure is less than 6 days? So if you recall from this section, the first thing that we're generally required to do is draw up your bell-shaped curve and plot in your population value. And your population will come from the first couple of lines in the question, where they'll say to you that in general, this is what occurs. So here they said to you that the patient recovery time from a particular surgical procedure is normally distributed with a mean of 5.3 days. So what they're saying here is that in general, it is a recovery time of 5.3 days on average. And so this is your population value. So when we work with a mean, and you'll find that in this learning unit, for this particular section, we'll be calculating normal probabilities and using the Z value, determining the final probability for a mean and for proportions. And again, you'll see that it'll follow through into Learning Unit 3 as well, where it will become a section we look at in a whole lot more detail. So we're looking at means and proportions to carry out a standard normal distribution for. And when they've given you the mean, it obviously signals to you then that we're working with a standard normal distribution of a mean. And here they've said to you that it is 5.3 days. So when they've given you the general figure, it is going to be the population mean, which is denoted by the symbol mu. And then they've given you the standard deviation, which is 2.1 days. And then they said to you that there were 26 patients that were sampled. And they said to you, what is the probability that from those 26 patients that were sampled, the recovery time from the procedure is less than 6 days? So in this case, just ignoring the word less than for now, your sample mean is going to come from the question. So your sample mean would then be the 6 itself, ignoring any words that were prior to it. So you have the sample mean, the population mean, the standard deviation, and the value of n. And again, when it comes to the section, the steps that we generally follow is that we draw up your bell-shaped curve, and as I had mentioned, you'd plot the value of your population figure down the center. So in this case, your population value is 5.3. Once you have the population value, you're going to look at what the question asked you and plot down together with the sample value. So as I said, we had plotted down the center the population mean, which was 5.3. Then you're going to look at what the sample value is, which is 6, and 6 would fall somewhere to the right. Remember, this diagram works as a normal number line where you have 0, it increases into greater numbers to the right, and it decreases into further negative numbers on the left. So a normal number line would have the number 6 somewhere on the right-hand side. And then they said to you, once you've plotted down that value, look for the words that they have included here, which says less than 6 days. So if you look at this diagram, less than 6 days means we would be going in this direction. So less than 6 days then says to you that we're looking at everything from this point onwards. So basically this whole portion that is now shaded. Now the rule when it comes to your normal distributions is that, and I'm going to draw up a diagram for you here, which is going to assist you when you look at these type of questions. If you have a figure that falls on the right, and the question, let's suppose, said more than 6 days instead of less than 6 days. So more than 6 days. So your value of 6 fell here. And if they're saying more than 6 days, they're saying in this direction, so further to the right. So if you have your bell-shaped curve drawn up with down the center your population value, and you then plot your sample value, and it says that it's moving away from the central line, then the rule is 0.5 minus. If it was here on the right-hand side, like in this example we're looking at, and they said that it is less than, which means you're moving in this direction, the rule then is 0.5 plus. The same would apply if you had the exact same diagram, but now your value is on the left of that central line. If they're saying to you that it's less than this value, so less than means you would go into this direction, the rule is 0.5 minus because you're moving away from the central line. And if they say to you more than this value, then it means you're moving to the right, where the rule is 0.5 plus. So this is the rule when it comes to your standard normal distribution. It's exceptionally useful to you when you are trying to determine and when you need to know whether to use the 0.5 minus rule or the 0.5 plus rule. It's exceptionally useful to you to draw up this diagram. So I'm just going to draw up the diagram for you again, but with everything on one diagram. So if you have the central value here and your value falls on this end, if you're moving away, it's 0.5 minus. If you're moving in this direction, it's 0.5 plus. The same here, if you have a value on this end, if you're moving away, it's 0.5 minus. And if you're moving towards the central line, it's 0.5 plus. The idea behind this rule is that if you draw up a bell-shaped curve and you draw a line down the center like we are doing, this is separating the graph into exactly two halves, where 50% or 0.5 of the data lies on either side of the central line. So if we are saying, like here, for instance, if the value is on the right-hand side and we're moving away, we're saying that we're not using this entire 50%. We're only using the portion here, which means we can say 0.5 minus this portion, and that would tell us our answer. The same mentality goes into the 0.5 plus rule. If we're saying plus, that means that we're saying that we're moving in this direction, which means that from this point, we're looking at everything on this end together with everything on this end. So it's the entire 0.5 here plus whatever portion is shaded on this end. So this is the idea behind the 0.5 plus and minus rule. So back to our question. I just want to draw up the diagram again. Down the center is a population value, which is 5.3. We plot the 6 and it says less than 6, which means we're moving in this direction, which would then say to us that our rule is 0.5 plus because we're taking everything on this half of the curve, of the bell-shaped curve, plus whatever is on the right-hand side. So it's a 0.5 plus rule. The second thing that we do is we're going to calculate the Z value. So the first step was we drew up a bell-shaped curve, we plotted down the central value, which is your population value. In this case, it's a mean, so it's your population mean. Then we determine what rule we'd be using, which is 0.5 plus. And in order to determine what we're adding, our second step now is to calculate the Z value. Once we have the Z value, we'll go to table 1 of your appendix, and that's going to give us the figure that we're looking for here to add to the 0.5 plus. So to calculate the Z value, the formula that we use is when it comes to a mean, like in this case, it's calculated by x bar minus mu over the standard deviation over the root of n. So in this case, x bar, if you had recall, I had written out, was a value of 6. Your mu was a value of 5.3. Your standard deviation was 2.1. And your x value was 26, since they sampled 26 people. So this would give you a Z value of 1.70. This is step 2, which you would then now take. Sorry, I had mistakenly written step 3 here. It's actually step 1 to draw up the bell-shaped curve. Step 3 then is to take this Z value that we had calculated, go to table 1 of your appendix so that we can determine what the probability is, and then we take that probability and we add it to 0.5, since that was the rule that we had followed. So we're going to go to table 1 now of the appendix. I'm going to project it for you, and we're going to locate the value in line with 1.70. So I'll bring up the table for you. Okay, so this is what the table 1 of your appendix looks like. You'll find it on page 446 of your textbook. And remember, we had a Z value of 1.70. How we identify and locate the figures on this table is, firstly, we take only the first 2 digits of this value and we locate it going down this table, so vertically. So 1.7 is what we're looking for, which, as you can see, is here. Then we're going to look at the remaining digit. And if you look at the heading of this first row here, so it has 0.00, 0.01, 0.02, 0.03, all the way to 0.09. So as you can see, the first 2 digits are always 0.0 across the table. And now the last digit from your value is going to tell you what the last digit is here. So it's 0, since it is 0 here, which means that this is what you're looking for. So in line with 1.7 and 0.00, your value is 4. 0.4554. So this is the probability that you have now determined from table 1 of your appendix. You will now take this back to your question. So as we had written out, and I'll just draw it again for you, this was 5.3, this was 6, we said less than, so it was 0.5 plus. We calculated Z saying 6 minus 5.3 over 2.1 over the root of 26. We had an answer of 1.7, which we took to table 1 of your appendix, and we gathered that the probability was 0.4554. Now we're going to take this value, and remember we said that is going to be what we add to the 0.45, to the 0.5. And so your final answer will be that 0.5 plus the 0.4554 will give you your final answer, which is 0.9554. As a percentage, you'll multiply that by 100, is 95.54%. So they almost always require you here to interpret your final answer. So they said to you, what probability that the recovery time from the procedure is less than 6 days? Remember, for these 26 patients. So all you're going to do is very similarly to what I had explained to you for Learning Unit 2, you just take the question and plug in your answer and manipulate it so that it will give you a closing statement. So you're going to say that therefore there is a 95.54% probability that the recovery time from the procedure is less than 6 days for the 26 patients that were sampled. So there's not much that you're going to have to make up or think of how you're going to give a closing statement. All you're going to do is just look at the question, manipulate it, and plug in your value so that you then have a closing statement. Okay, so that's the first question, and this is where we had a mean that we were working with. Then we have in the second question a proportion that we're working with. Now, again, very similarly to something that we had come across in Learning Unit 2 with your binomial distributions, you're going to find here for proportions, you're either going to have a percentage given to you, or they're going to say to you so many out of so many. So you'll calculate R over N, and that would be your proportion. So depending on the question, you'd either be given the percentage or you'd be given the values, and you'd be able to calculate the proportion. So in this question, they said to you, according to a community survey, 87% of citizens over the age of 25 have earned a high school diploma. So here's saying to you, and exactly as we had done with the first question here at the top, since we're working with proportions, you will have a sample value, which is denoted by the letter P, and you will have a population value, which is denoted by the symbol pi. So here you'll have a general figure that will be given to you, which will be the population value, and you'll also come across, again, just like with the mean, a sample value as well. So in the first sentence, they said to you that according to a community survey, 87% of citizens over the age of 25 have earned a high school diploma. So this 87%, they're saying to you, is in general what occurs in this community. So this is then your population proportion. It's your value of pi. And I'm going to immediately draw that up on your bell-shaped curve where we'll always be putting our population value down the center. I do strongly suggest to please convert it to a decimal and plot it on this diagram, because you'll be required to also use decimals in your calculation of the Z value. So it would be 0.87 going down the center. Then they said to you, suppose we are going to take a random sample of 200 citizens. So N is equal to 200 in this age group, and calculate what proportion of the sample has a high school diploma. What is the probability that the proportion of people in the sample with a high school diploma is less than 85%? So now we're going to, firstly, the 85% immediately signal to us that this was the sample value, the p-value. So we know what the sample value is. This is 85%, and the population was 87%. So we can plot 85 onto this diagram, which would be somewhere here. And then they said less than 85, which means we're going further to the left. So we're moving away from the central line. And if we're moving away from the central line, as you know, the rule is 0.5 minus. So I'm just going to clear the screen so I can look with the question. I need some space. I'll draw out the diagram again, and we'll draw it up with more space. So this was 0.87. 0.85 was somewhere on the left, since it's a normal number line. 0.85 would be first, or 85% would be first, and then 87. And they said less than 0.85, which meant it was a 0.5 minus rule. So we know that 87% was, sorry, wrong symbol. This was pi, and then your 85% was p. Your sample size was 200. And they said to you, what is the probability that the proportion of people in the sample with a high school diploma is less than 85%. So we know the rule that we're using at the end of this. We're going to say 0.5 minus a specific value. Let's now look at how to get to that specific value. So we're going to use the formula for Z, which is P minus pi when we're working with a proportion over the root of pi multiplied by 1 minus pi over n. So this is a Z formula when we're working with a proportion. So the Z formula then, based on it, P is 0.85, so 0.85 minus pi is 0.87 over the root of pi, which is 0.87, multiplied by 1 minus pi. So 1 minus is 0.87 over n, which we said was 200. This would then give us a Z value of negative 0.84, which we are then going to take to table 1 of the appendix, and we're going to locate this value. So we're looking at minus 0.84. Now, whenever you have a minus sign ahead of your Z value, so it was minus 0.84, you ignore the minus sign from this point on, and you work with only the 0.84. So the first 2 digits, remember, are located vertically on this table. So we're looking for 0.8, which is here. Then we're looking for, remember, the first 2 digits will always be 0.0, and your last digit will be the last digit from the Z value, which is 4. So you're looking for 0.04, which is here. So all the way down to this, in line with 0.08 and 0.04, sorry, 0.8 and 0.04, you have a p-value of 0.2995. So this we can then take back to our question. So as you had seen, and I'll just draw this up again. They said less than 0.85, which meant it was the 0.5 minus rule. We said that Z was 0.85 minus 0.87 over the root of 0.87 multiplied by 1 minus 0.87 over n, which was 200. This gave us minus 0.84, which we then took to table 1 of the appendix. We ignored the minus sign. We located 0.8 going down, 0.04 going across, and that gave us a p-value of 0.2995. So now, according to the rule, it says that the probability is then 0.5 minus whatever answer you had got from the table, which is minus 0.2995. That is 0.2005, which as a percentage, if you multiply by 100, is 20.05%. And then to answer the question, what is the probability that the proportion of people in the sample with a high school diploma is less than 85%? You would then say that there is a 20.05% probability that the proportion of people in the sample with a high school diploma is less than 85%. Okay, so that's it for today and the end of all of the videos for Learning Unit 2. I hope this has been of use to you and you can use it to practice different types of questions. And I will see you again for the start of Learning Unit 3. Thank you guys. Cheers.